Okay, video 3. Here we are to connect all the pieces together. Here is my setup. So right here I've got something that's going to make some sounds. This is a little drum machine sequencer thing. You're going to see in this video that I changed the sounds from my weird mouth sounds that I was making before to more traditional drum sounds. That thing is connected to a speaker. That speaker is now just sending out audio over to my microphone, and so that's the signal path. So this thing isn't connected directly to my computer in any way. It's just sending audio in the room, and my microphone is being used to pick up that audio and then go through that pipeline of stuff that we just talked about a second ago. Okay, so here we go. So the next and final part of this pipeline is processing. Processing is our program that we're going to use to make visualizations for this. And so here it is. In this file, you'll see a whole bunch of code. The first stuff is a library thing. So this is a library that we're going to install and use. And so you might have an error that comes up, and you might have to go through the step of adding a library. You type in OSC here, OSC, you'll see OSC P5 come up. Mine's already installed, but you'll probably need to install this. So install that one. This is a library that lets us send these OSC messages, the same messages that we've been sending previously in our other programs, back and forth between each other. Okay. So we've got OSC going there, it's installed, and now we're good to go in our code. You shouldn't need any other libraries for these examples today. So what the code is then doing is basically, there's a few things that I'm doing here. So the first one is I'm doing this moving average thing. This is basically just providing a bit of smoothing to the data. If you saw the output data of Wekinator, you saw that these things are like jumping all over the place. They're a little bit noisy. They're bouncing around a lot. So if we do some averaging on them, it's going to help us make things a little bit smoother. I also have some variables that I'm using. So these are sort of 3 variables sort of corresponding to each one of those states that we described before. But I'm using them eventually to create colors that we'll draw to the screen. And then these are our decrease and increase amounts. So basically, whenever I get a positive message from Wekinator saying this sound 1 got identified, I'm going to increase these variables here by a certain amount. And whenever I don't hear that, I'm going to decrease it by a certain amount. If you put bigger numbers, things will change faster. If you put lower numbers, things will change slower. So I've got it set at 50 and 20, and it seems pretty good, but these are things you could change in terms of changing the overall behavior of the output animation and the thing that you're going to then create. Okay, so we can set thresholds for ML for this as well. So right here, we're basically saying, because of that noise that we're seeing in the output messages from Wekinator as well, unless we get a really clear signal, like this is like above 0.8 and these ones are both below 0.2, then we're not going to consider like a positive message. And so these values here are sort of like an error checking step. They're saying we're going to make sure we've got a really strong message, so it really thinks that it's this type of sound or that type of sound before we actually do anything. In this section, we've got a couple options here. This is a setup loop. This is sort of getting the program ready to go. You'll see that we have an option to turn this into a full screen thing. If you want to run full screen, you need to uncomment this. So press delete, and then comment this one out. Okay. We're going to do that though for this example. I'm going to use full screen later when I actually turn this into a light projection that I'm going to have in my space. To enhance the music and sort of the experience that I have that I'll show in the next video. So anyways, we're going to use this thing. This is basically saying draw an 800 pixel by 400 pixel window to the screen with the stuff that this code's trying to do. We're going to start up some OSC communication, and so you saw that 12,000 port thing show up in Wekinator before. Use these defaults, and so yeah, this is like the basic thing. So we're getting information from Wekinator, and we're going to draw some stuff, which is cool. So the next thing is setting up the averaging. So this is just a task to set up the averaging, that smoothing that I described before, and then we're all set up. We're good to go. Your next loop is called a void, or your next function is called the draw loop. Basically, whatever is in the draw loop, inside the brackets of the draw loop here, we'll just keep looping around, and I'll keep running and activating this code. So basically what I have in this draw loop then is a set of conditional statements saying You know, if the first variable is higher than our limit and these two are lower than our limit, then do something, and so on and so forth. And so basically what it means is that if, you know, if Wekinator sends out a 100 message, then turn up the first variable and turn down the next two. If we get a 010, then it says turn down the first one, turn up the second one, turn down the third one. I gotta put this as plus. And then similarly here, there we go. And so if we do all these things, we're going to have this output that gets created. The last one is like if we have all zeros coming out or something, not one of those three states, then you know, we could, all of them are going to decay basically. And so what this actually is going to mean is that if we get a positive signal, we're trying to take this number, ramp it up, and then let it decay over time in a nice sort of gentle way. If we don't get any messages, just decay everything. And at the very bottom, we've got this sort of constraint thing here, which is saying that if we ever get below 0 when we're decaying and subtracting numbers, just keep it at zeros. Or if we get above 255, just keep it at 255. These limits are in terms of the representation of colors in this program processing. There's plenty of tutorials out there, so if you're like, oh, what is processing even about? I can't go into this video, but there's lots of great tutorials on processing.org and ways to sort of get into learning that kind of stuff. Okay, so our colors now that we're going to draw to the background, this is what we're going to try to do, are then going to be a function of these three variables we created. So decay 1, decay 2, decay 3. These numbers are going to go up and down depending on the messages we get in because of the things we do inside these brackets here. And they're going to make change. And we'll sort of see what happens when that change gets represented here as basically the whole color of the window that we have. There are some other stuff here, other things in the bottom here. These are other messages or other functions, sorry, that are going to be run and called to do stuff up here. So yeah, so here they are. There are other functions. The ones are doing averages. This one's actually sending and receiving OSC messages. So it basically takes care of all the stuff. The one thing to know about these messages is that this is where the parsing happens. Parsing means like taking apart a message and sort of getting the information from it. Because I set my output message to only have 3 numbers, I have 3 Fs here. Each one stands for this thing called a float. A float is a non-integer number. It's a real number, so it's like 1.26735, whatever. And I'm going to get 3 of those in each one of my messages. I then go through each one of those little components and I grab all 3 messages and turn them into parameters. And I then add them into my averaging and the stuff that I'm doing. If you want to extend it and have more output numbers, so have more states or have more sounds you can clearly identify, you'd have to change this to have more numbers that it's looking for from the message sort of thing. This is a spot where you might get errors coming in. So think about that message that you're sending. It's looking for a message with 3 numbers in it, so we got to make sure that it's set up to receive a message with 3 numbers in it, sort of thing. Okay, so that's it. So we're here, we're ready to go. Let's run this thing and we'll see what happens. So here is my window. You can see that stuff is happening. There's colors that are changing. Let's open up this guy too. So here's my Wekinator. I've trained it on different sounds like I mentioned. And I'm going to just slide this down a little bit so you can see everything here. Okay, so I've changed it on different sounds. My sounds are going to be this. So we've got bass drum sound, which is cool. And so when it hits the bass drum sound, we're sort of getting that like 100 output. 100 corresponds to a red drawing to the screen. So if I hit a bass drum, I get red drawn to the screen. If I hit this like snare sound, I get blue drawn to the screen. And when I hit sort of a gongy cymbal sound, it's going to be the last one. So here's my green. That's a different sound though, right? There's no sound there. Interesting. So I didn't train on that sound, right? I trained on that sound. It's hitting the blue. It's kind of picking up as green. So it's not perfect, right? But it's interesting. So so here we go. We've got the ability now to mix colors and sounds. So I'm going to set up a beat. Okay, here we go. So I've got a beat set up now on my little machine. I'm going to play it. Which is cool. And so the possibilities are now limitless because we can clearly see that there's a connection between our sounds and what colors get drawn to the screen. We could use those, these numbers. I've got 3 numbers that I can use to do anything. Maybe they change the rate at which something moves around a screen, or the size of something, or the color of something, or something else. Like there's basically unlimited possibilities with this. And so, this is a very basic, simple application. There's some value in that because if you get too complicated, then things get a bit crazy and you don't know what's happening, and there's a direct connection between the sound and the effect that you're having. So in the last video here, we're good to go. We've got this thing working. We can identify sounds and do something intentionally to respond to those sounds. That's the goal of all 3 of these things. In the last video, I'm going to sort of show the application in the way that I would use it, which is to now use a full screen version of this to run a projector, and then use that projector as the lighting in my performance space. That sounds cool, right? So now I have dynamically responding lighting, which not only just responds to like how loud something is, but actually responds to what the sound is in different ways. So here we go. I'm going to do that in the next video. Thanks for watching, and last piece here coming up.